Good afternoon, everyone, and welcome here. My name is Mariella di Giacomo. I am a database engineer at ViaSat. It is my pleasure to be here. How many of you are familiar with database replication? Great. How many of you ever tried Postgres and MySQL replication? How many of you ever tried Postgres replication? And how many of you ever tried the MySQL replication? Okay, so there is a good mix. This afternoon, I'll be presenting the main features and dissimilarities of two great, world-famous database replication solutions, MySQL Group Replication and Postgres Bi-Directional Replication, also known as Postgres BDR. And primarily in this presentation, I'll be covering Postgres BDR version 1, which is the open source and free accessible version of Postgres BDR. I know everybody will be inspired to use them, and by demonstrating their strengths, I'll be able to convince you that both are great strategies for high availability, especially when you want to achieve the following three things: fault tolerance, automatic failover, and multiple concurrent write capabilities. Both solutions will simplify and optimize the management of high available, large scale, and free accessible database architectures. I will briefly introduce database replication and, of course, Postgres and MySQL replication. I will explain the main features of Postgres Bi-Directional Replication version 1, as mentioned, the open source version of Postgres BDR. I will cover the main characteristics of MySQL Group Replication, and I will show the main similarities and differences between MySQL Group Replication and Postgres BDR. What is database replication? Database replication is the process of copying data from one location to another. Electronically is the frequent copy of data from one or more databases in one or more database servers to one or more database servers. Why is database replication so important? Because it's had the characteristics of being redundant, allow redundancies, and allow high available and scalable architecture for databases. And PostgreSQL and MySQL, both open source relational database management systems, allows and support database replication. What are the main high availability solutions for MySQL and Postgres that can be achieved using database replication? Of course, master-slave, a single master to one slave, standby or multiple slaves. So when does a person want to use a master-slave replication? One wants to achieve data and node redundancy, and of course, read scalability. Master-master replication is a special case of master-slave replication where the master is called also active master, replicates data to a slave or standby copy, where it's always available to become a primary in the case the master fails or dies. That's why the name passive master. Multimaster replication. Multimaster replication, of course, is a special case of master-master replication where the design allows two or more active masters. Postgres replication. Postgres replication has been supporting two main types of replication: physical, at the block level streaming replication, and where the records inside the wall-head transaction logs are sent to the replicas, to the standby nodes. It's suitable for high availability and because it requires usually high bandwidth. And the other type of database replication supported by Postgres, which is also the recent, is logical row-level streaming replication. Postgres sends data only through row-level changes to the replicas, and is suitable for remote high availability because it has a lower bandwidth, and it's streamed at commit changes after the changes are committed. Where committed here means the changes are saved persistently, permanently on disk. MySQL replication. MySQL has been apported two main types of replication. Started with event-based replication, where the events are sent to each slave, and the events are sent in statement, row, or mixed format. The latest version or type of MySQL replication has been global transaction identifier-based replication. The GTIDs are sent to each slave server. It's complete transaction-based. It sends the information using statement-based and row-based replication. And it's important to focus on global transaction identifiers-based replication, and for Postgres on logical replication, because those are the two types that are used for Postgres BDR and MySQL group replication. And I would like to note that in the slides that will be posted on the website, there is a more descriptive information on both the Postgres and MySQL replication for those that are not familiar with it. But I couldn't cover everything on this talk. Postgres Bi-Directional Replication, also known as Postgres BDR, and primarily Postgres BDR1. It's been designed and implemented by a company by the name Second Quadrant. It's a groundbreaking asynchronous multi-master logical replication for Postgres databases with high availability across region. It was designed for geographically distributed PostgreSQL databases for small and large environments. It's important here to note the word asynchronous and multi-master, even though Postgres BDR can offer also single master scenario like MySQL group replication. So the main headlines of Postgres BDR can be summarized with the words multi-master, asynchronous, eventually consistent because it's based on logical replication, which is asynchronous. So at a given time, the data may look different from different nodes. And being a multi-master architecture, it may occur that different transactions will run into conflict situation. It does use an optimistic conflict detection mechanism and resolves also the automatic conflict as well. Let me give a brief history about Postgres BDR and its related versions. It started from Postgres BDR 1 in 2014, has been in production since then, and Postgres BDR 1 has been open source, fully accessible, and support up to Postgres Server 9.4. The latest version of Postgres BDR that's been released in June 2018, which is also called the Postgres BDR 3, supports the latest version of PostgreSQL Server, but it's only for paying customers. Which are the main characteristics of Postgres BDR? As I mentioned earlier, it's a multi-master failover tool or architecture, but offer also single master scenario. Each database receives changes from every other member. Each node in the group has its own copy of the data, so it's not a shared storage architecture. Changes to one node are replicated to all the other nodes after commit. So they are all replicated after the commit changes. And the data, as I mentioned earlier, may look different at the same time on different nodes. That's why eventually consistent architecture. It uses row-based individual row values logical replication, and it's bidirectional, of course, because all the nodes can accept writes, and ensure that constraints are always consistent on every node, and the nodes as well can accept read queries from clients. I don't have to communicate while doing so. What are the main characteristics of Postgres BDR? What are the main components? Group communication system, transaction component, a recovery component, and a multi-primary component. We will observe and examine each one of them, starting with group communication system. It's based on a custom protocol on top of the standard logical replication. It is a fully meshed group on node. Every node communicates with any other member in the group and requires a connection string for any new node to at least one of the existing nodes. It's possible and it supports SSL because it's part of PostgreSQL. So the main things to remember here is that it's based on logical replication and has on top a proprietary custom protocol, and it's fully meshed group on nodes, so every node communicates with all the others. Let's progress to the transaction component. At commit time, the changes are propagated to each node through logical replication and asynchronously. It uses global sequences to identify transactions and to make sure there are no conflicts on the transaction as well, and provides eventually consistent data on Postgres BDR3. The user, the administrator, can choose between latency and consistency, which means it's possible to increase the consistency level with some drawback latency. So it's possible to have a stricter level of consistency with Postgres BDR3, while with Postgres BDR, all the nodes are in eventually consistent mode. Recovery, the recovery component. How does recovery work? If a network link goes down, the messages are piled up, and here I'm talking about the database manipulation commands are all stored, and when the link comes back up again, the nodes will catch up. If a node goes down, what does happen? The database is still available, provided that half of the nodes is still running and in healthy status. And however, if a node goes down, the data definition language statements on Postgres BDR1 will block the continuation of the business, which means, what are the drawbacks of this case? The commands related to the cleaning of a dead node have to be very quick, and unless all the statements that will arrive to the databases do not have anything else. And the final component is multi-primary, the multi-primary component that allows to have every node in writable mode from the users. Why do people want a multi-primary scenario? A multi-primary scenario will always allow for high availability because all the nodes are in write mode, and if a node goes down, there is nothing to be changed, and the queries can always propagate no matter whether they're read or write mode. And also allows for a faster failover. Usually when you have a single master scenario, a new node has to be delegated, promoted to primary master, and even though the time it's very invisible, or it's invisible to human eyes, it always takes longer than having all the nodes in write mode. There are some limitations though, and there are conflicts to be resolved. So, for example, when two transactions are executed in parallel and they touch the same rows on the same set, there are conflicts. And how are those resolved in Postgres BDR? The last updates will always win. So this is very different from MySQL Postgres replication. And so the difference between Postgres BDR and MySQL group replication is that on conflict resolution, on Postgres BDR, the last update wins. On MySQL group replication, the first wins. Let's progress to MySQL group replication, just to mention it. What is MySQL group replication? MySQL group replication is the core engine of MySQL NoDB cluster. And what is MySQL NoDB cluster? It's the complete, full, high available solution that MySQL 8 has delivered as open source and free accessible. It consists of three components: MySQL group replication, MySQL shell, and MySQL router. And the MySQL group replication is the engine, is the core that consists of a group of redundant nodes that allow high availability. From a server perspective, it's a plugin, it's a library, and is always capable to maintain high availability of redundant nodes. It replicates using XCOM, which is a variant of the Paxos protocol, the system state to a set of database servers, and provides high elastic group of database nodes because it's very easy to add and remove nodes, and allows, of course, read scalability and at times write scalability, and we will go over these parts. So look at the main highlights for MySQL group replication. It will allow many clients, many servers if you use many servers in write mode or only, in read and write mode, and write everywhere if it's in a multi-master scenario. Allows also elastic group of node because it's easy to remove and add nodes. And it's based also on an agreement among the nodes. We'll see soon what that means. As I mentioned earlier, MySQL group replication will allow always continuous business on distributed databases. What does that mean and when does that occur? Provide that the healthy, live, and functioning database nodes that are in the group is always higher than half of the total number, you will always be guaranteed that your database is always functional in business. And assure that the database will be always available, even in degraded performance or scalability. Isolate server failures. Let's go over some of the history of MySQL group replication. It's been open source since December 2016 with MySQL 5.7.17. It's a core engine of MySQL NoDB cluster. And what are the main characteristics of MySQL group replication? The main characteristic of MySQL group replication consists of its group communication system, transaction recovery, and multi-primary. Let's start with the group communication system. It's the foundation, the building block of MySQL group replication, and provides membership. What does provide membership mean? All members have to agree on who is a member. Each member has the list of all the members, and they agree on a consensus based on the Paxos protocol. And in the group communication system also guarantees that all the messages are totally ordered, they're broadcasted to every node, and all the messages are sent in the order they are received, which means there's not going to be never a message that's going to be misplaced. The transaction component. What does the transaction component guarantee? It guarantees that there's not going to be ever a split brain scenario, what is a split brain scenario? Is a situation that is going to cause an inconsistent database state and provides eventually consistent data because the data could be seen in different times in different states. And how does guarantee no split brain scenario? Allowing that enforcing that the transaction is always committed on a number of nodes which is higher than the half of the number of nodes in the group. This is an example of how the transactions are propagated, and they are virtually consistent, which means that they are eventually consistent. Provided that the majority of nodes always respond synchronously to the certify operation, the commits will always occur, the transaction will always be committed, no matter what the other less minority, or the less number of nodes is not completed yet the same transactions. Which is the recovery component. The recovery component is the component that's going to take care of the groups that are added and removed to the group. A node can join a group, a node can catch up with all the transactions, will never be online until it caught up with all the transactions. A node can also be easily removed from a group. All of this is very easy to be done, a simple command that can be used from a MySQL shell or any program that's going to be running. And finally, the last but not the least component is the multi-primary, where each master can concurrently accept writes from the external users. One, the people want to use multi-primary to have a higher throughput, especially if the single master node is bottleneck on CPU and number of database connections, and to achieve a faster failover because all the nodes are write mode, which is the penalty that is associated, the conflict resolution in case two transactions that are executed in parallel on different master servers. And in this case, the first update wins. And as I mentioned earlier, MySQL group replication by default allows eventually consistent data, but since the version 8.0.14, you have other options. You can also augment the level of consistency with some drawbacks in latency. This image shows the single master scenario and the multi-master scenario and fail nodes as well. Let's go over the comparison, or at least comparing MySQL group replication and PostgreSQL close to each other. From a license perspective, MySQL group replication is still free accessible open source, while PostgreSQL is only for version 1, but not for version 3. From a network latency perspective, MySQL group replication requires, so I would suggest to use it when you have a low network latency, while PostgreSQL was designed for geographically distributed database servers and is fully based on a single replication. When it comes to high availability, they both support a single master scenario and multi-master. They both require a group with 3 number of nodes if you like to be still fault tolerant after one node dies. And when it comes to the max number of nodes in a group, I would say more or less allows up to 9 servers in the group. And PostgreSQL theoretically allows up to 48, but practically so far, the most use of it has been with 9-10 nodes. And it's primarily caused by the communication around all the nodes. And what about the creation of the group? For in both cases, you need to have a node where Postgres is being installed or MySQL has been installed. You are going to create the group in both cases. When it comes to the additional nodes, all the nodes in both cases can be added concurrently. And when it comes to the automatic node removal, and as I mentioned earlier, PostgreSQL does not have a built-in mechanism to clean completely the parts related to a node that dies. And on MySQL group replication, you can run a simple command and remove the node. And the replication on MySQL group replication, we can set as virtually synchronous replication because the majority of the nodes have to agree and acknowledge on the certification phase. PostgreSQL is asynchronous, it's based on logical replication. And data manipulation language commands are virtually synchronous or executed virtually synchronous on MySQL group replication and are asynchronous on PostgreSQL. The DLs are virtually synchronously on MySQL group replication, while asynchronous on PostgreSQL. And there is no difference for the so-called DDL statements like create a role, create a user on MySQL group replication, but there isn't on PostgreSQL. And on both cases, the tables must have indexes. The transaction identifiers are supported using GATIDs and MySQL group replications. And on PostgreSQL uses logical streaming replication with the row level. and the multi-master conflicts. The multi-master conflicts are in MySQL group replications resolved automatically, and but you have to, I would suggest not to have in multi-master scenario have database manipulation languages executed on nodes that are different than those immediately after than those where the DDLs are executed. And more or less the same is true for Postgres BDR. You have to be careful managing your database schema. Let me conclude with the main difference and similarities. The first that is related to the version. One is freely accessible, and one, unfortunately, the latest version are not any longer. Both products have overall automated administration and low database node maintenance. Postgres BDR was designed for being redundant geographically and distributed, while Postgres group replication is also a redundant solution but requires low network latency. It could be used also for higher levels or higher values of network latencies, but there are some drawbacks to watch out. And both designs support the same number of minimum and maximum number of nodes, and both solutions support single master and multi-master scenarios. These are some references for those who would like to learn more about it. Thank you.